Here's part three. Now, this question again kind of points at: are you realizing that these sine, cosine, sine, and tangent values actually represent a triangle? And you should know, like, this page is meant to be done without a calculator. So, where it's not meant to like grab a calculator and try to like type in the angle. One, because the angle is not given, and two, because you honestly don't need it. As long as you have the structure in place and you're kind of realizing the sine, cosine, and tangent are just functions. And so let's look at 2a, which will be the focus of this video. And we're trying to figure out the length of AB. So it's marked with a question mark. I'm going to go ahead and mark it here in pink just to highlight it. In the end, we want this side. And we can use Trig to do it, even though we're not going to use a Trig sheet or even our calculator. What we need is just what we know already about trigonometry and maybe the structure we've been pushing in class. Let me try to demonstrate what I mean. And so we need to notice in this problem that we are given this reference angle right here, although we don't know what it is. The problem calls it BAC. If you remember the naming convention, BAC means the angle is actually located at A. Just for shorthand, I'm going to call it theta. Theta is just a Greek letter typical for you to use for unknown angles. And so from this point forward, I'm just going to refer to as theta. Well, if we need to find the pink line here, which is a hypotenuse, according to angle theta, we're still going to use the same trigonometric thinking, meaning we need something to help us find it. Well, luckily in this problem, we were afforded this side, which is 48. And so we're going to start the same way we've always started, using theta as a reference angle. We need to find the hypotenuse. We're given this green line, and we can identify this green line as being the adjacent side. Adjacent, of course, because it touches theta, and that's what we call that. So we're going to start out by writing a ratio just like we always have. So we need to solve adjacent over hypotenuse using a reference angle of theta is the same exact thing as this again, because we are trying to always compare two similar triangles. Okay. In fact, we're going to continue the same way as well. So on our actual triangle side, the adjacent side for this is going to be 48. And the hypotenuse side is unknown. So we're going to I'm just going to keep calling it H. Even though it calls it a question mark, I'm going to keep calling it H. On the other side, though, we need to replace this, of course, with A over H, which is cosine, using theta as our reference angle. And again, I think the problem calls it something else, but we know that A and theta are just the same thing for us. So usually we go to our trig sheet or we go to our calculator and we try to find the replacement value, the ratio value for cosine, the A over H value for cosine. But we don't have an angle here. But if we look up top, we were given some information that was a little bit weird then, but maybe not so weird now. We need to replace this with a value. Well, we actually need the cosine of theta value, the cosine of angle A. And they actually afford that to us. We just have to pick out the right one. Now, they gave us more information necessary, which is okay. But here is a cosine of BAC. And again, please recall BAC is the same thing as theta for us right now. I just didn't want to use a three-letter convention. I renamed it theta in our problem. And so these are all theta because they all occur at A. And so the replacement actually is going to come from the top. So we have this. I'm going to switch to black ink here. So we have this 48 over H ratio on the left, and the cosine value will be replaced here as 12 over 13. Now this isn't the value that we're used to seeing in our trig table. We're used to seeing like a decimal value, but we can trust this information up here. We were told this information up here, and so we can trust the cosine of angle BAC, which is this one that we've renamed theta, is 12 over 13. Well, now we just have to do an algebra problem. Now we just have to cross multiply and divide. And so crossing it up, we get 12h is the same as 48 times 13, which I can't do in my head, so I'm going to go and grab my calculator here. So 48 times 13 is 624. And then, of course, solving, we'll divide both sides by 12, and that means our h value is 52. And of course, this fits in very well with the fact that it has to be larger than 48. It certainly is. We don't have any other angles to compare, so we can't do that kind of comparison. But in the end, if you notice, even though I kind of changed the context and I took away the trig table and the calculator, it's really the same thing. One, we have this actual triangle that we're trying to solve. We pick a reference angle, even though we don't know it, and the side we're trying to solve, and the side we're able to use to help us solve. And that's got to match um, this referencing value right here, this reference ratio. Now, again, we usually go to a trig sheet or a table to find, or a calculator to help us find the replacement value for cosine of theta, but we have it right listed on top, so we can use 12 or 13 as a trustable value for that. In the end, it's just going to be an algebra problem, and we just solve down to get a value. In this case, it's going to be 52. Now, we're not going to do part B on video, but you can assure yourself that if you use A as a model, this information is the same. Now, I am trying to trick you a little bit because I'm giving you some square root values, but that should not trip you up too badly as long as you hold true to the structure and you realizing that we always just need another ratio to reference, and those are there. So just be careful picking out your reference angle. Again, please notice it is kind of pre-selected for you. One, because it's marked in your diagram, of course, as angle B, but also if you notice here, ABC, 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 B is always in the middle, therefore it is the angle at B. All right. So I'll bring video 3 to a close. Again, I'll have the answer to this posted online. I'm just not going to do it on video because, well, I think one is a good model. It gives you a chance to try the second one. All right. So if you have questions, make sure you let us know. That's going to end part 3. I'll see you in part 4.